G'day, Michael here. I'm doing, it's not the first test print, but I think it's going to be the first successful one. This is, well, my 600mm cube, more or less, intended to be a CoreXY machine. But for the moment I'm using Cartesian to debug various things. And it's working quite well. Currently it's laying down a track that's 1.6mm wide and 0.6mm thick. It's not a volcano head, it's only a, I don't know what that block is called, but it's one of the little flat blocks. But in any case, I'm getting about 5 cubic millimeters a second out of this extrusion arrangement. I might be able to bump that up to 6 cubic millimeters a second. But for size reference, the part that it's printing right now won't fit on my i3. Well, my i3 clone is, the typical 200mm square print area will not accommodate this part. So it gives you an idea how the size of the machine if you've got a reference to something else. So I'll just zoom out so you get the size reference there. Now what's new about this machine is that, well, there's a few things. The whole thing's a solid welded steel frame, so there's no parts that have got bolts and play in it involved with actual frames. The only part of potential looseness or movement is actually the bolting interface between this component and this extrusion, other than of course the rollers on the diagonals. I had some concern about the smoothness of this linear arrangement, but it seems to be extremely good. Proof of the pudding will be when this part's finished. But anyhow, I'm just aiming to show the bits and pieces that I've got running currently. I'm using a wider belt on the x-axis and two 6mm belts for the y-axis. And typical Cartesian arrangement. I've made these protective housings to hold the limit switches. I've got things temporarily soldered just to find my feet for the cabling. I'm waiting on some new drag chain. You can see here I've got a 2 in 1 out assembly, but I'm testing the extruder. This is a Tivo Titan, but I found the motor wasn't up to delivering the torque that it needs for this kind of extrusion. So I've put a regular, commonly used, I'm not sure of the rating on this guy, but it's one of the regular ones like you'd normally use in motion for a, like a typical Cartesian printer, instead of the little half motor that they have with these extruders. Alright, so that's that. Another unique thing is, I've been a little bit fed up with the spring-loaded supports for the print beds. This aluminium plate is 6mm thick, and typical aluminium plate is kind of unrolled from a big roll, and so it's got a tension built into it. And this had quite a hump in the centre. So what I've done is I've got focus. I've got a bolt in each corner and in also the centre of each run. So I've got a total of 8 of those bolts. Now what I've done is I've put those bolts, they're 12mm bolts, I put them in the lathe, faced off the top surface, which is underneath the metal plate you can't see. Drilled and tapped a hole down the centre. And then I'm using these 6mm countersunk X drive screws to fix to it. So that bolt is a solid object determining a fixed height, and the top screw basically just fixes to the top of that bolt. So it's very sturdy, there's no spring in it. My concern was that the mechanism wouldn't be very forgiving in the case of a collision with a dollop of filament. So I guess I'll see once this has worked its way through this part. This looks very slow, but the sheer volume going through is actually quite high. You'd be going very fast to be pushing this through a 0.4mm tip. This is a 0.8mm tip. If you double the area, at a given pressure, you can move twice, so 4 times the volume of material through the given orifice size. So yeah, it's actually pumping through a lot more material than it shows. Yeah, aim to put a volcano on this guy yet. I'm just finding my feet, making sure everything works that I've got drawn here and created here. Alright, so that's that. Now I mentioned these feet. Now these are to adjust the flatness. Focus. Those 8 bolts are to adjust the flatness of the platen. To adjust level of the bed, I've actually got 3 lead screws. So I've got, well, a lot of mess around here. So I've got the stepper motor there. You can see the belts are kind of crossing over. That's just basically as a tensioning arrangement. So the motor's tensioning one belt, and there's an idler over there tensioning the other belt. There are 2 pulleys on this shaft which basically act as the synchronizing between all the shafts. So you've got this shaft, that shaft, and that shaft synchronized by this one, and the motor's acting as a tensioner for one belt, and that idler's acting as a tensioner for the other. Okay, so each one of these, focus, each one of these nuts is a point of adjustment for the level. Focus. The point of the level of the machine. So level is achieved by those 3 lead screws, but flatness is achieved by these, I don't know, support bolts, I guess you'd call them. Kind of a standoff. Well, I guess that's it. More testing to be done. I've got to tidy up the wiring. I'm waiting on a drag chain. The one I had was not big enough for all the cabling that I've got to install, so I've got this temporarily in place, but I will have to put a much larger drag chain to power up the second extruder assembly. Yeah, I've got a synchronizing bar between both sides. See this side to where the actual motor is. I've got a small reduction on that so as to be able to get enough torque from this motor, produce reliable prints. Well, that's about that. The controller's still out on the bench, the rat's nest of wiring. I intend to, well, when I close in this side here, I intend to mount all of that and the power supplies to that panel. Now the bed heater is 24 volts. It's let's see if I can see it properly. Bit of a bad angle here. Focus. So it's a 400mm square silicon bed heater that seems to be doing the job of heating it up quite well. This platen was actually made for a different printer, or well, the same printer, I guess, but a different size. I didn't anticipate being able to get 600mm square at this frame initially. So it's the platen is currently 550 by 500, and that heater is 400 square. So what I intend to do is actually get a mains powered silicon heater on a much larger piece of aluminium. One cute thing that happened with this, by doing it the way I have, we have a printer that's kind of open on the top. It's really quite weird. It's like standing in front of, you know, your dinner table. It's about the same height as a typical kitchen bench top. So instead of sort of reaching inside a frame to pick up your print, it's basically presented to you on top of the printer. It's quite a different feeling. It's almost like working at a workbench or something like that. Yeah, well, I guess that's it. I've got nothing more to say at the moment. It's all a work in progress. So, I guess that's it. Feel free to like, share, subscribe, ask a question, leave a comment. Bye for now.